All right, so let's take a look at the fifth assignment. The fifth assignment um, is built on top of what we've been working on the last couple of sprints, creating the infrastructure for a middle tier, and where we have deployed a server that can host a Java data model that uses a CRUD repository that exposes a relational database through JPA, and all that exposed through a RESTful service. This week, it's going to be focusing more on the on being able to integrate with that with our relational database exposed through the RESTful service through React. Right. So last week you worked on installing the React framework. We're going to start using it earnestly in the upcoming sprint. So at the end of this sprint, you'll have learned how to use some of the simpler aspects of React. We'll add more as we go and progress. We'll add some new features, new skills as we go further into the project. Let's go over some of the design aspects of the assignment. I might have this wrong. I think this might be 3, and this might be 2. I'll fix it up. But basically, last couple of sprints, you've worked on a couple of data models that were specific to each team. Team number 1 focused mostly on 2 use cases. One that related service providers with their services that they provided, and also relating any service to the categories that they live in. Right. So that was the focus of Team 1. And they might have worked on a couple of data models in there that were either a user, a service, and or a service category, right? And you should have created several one-to-many or many-to-many relationships between these different classes, right? Whereas Team 2 focused more on the creating questions for specific service, where you might have one service related to many different questions, and for different services you have different questions, and then a many-to-many relationship that related a service provider's answers for a particular question. So a 3-way relationship there of a service provider, a service and a question, and then the service answer that that particular provider gave for that particular question. So there too, there were some opportunities to play around with JPA, one-to-many and many-to-many relationship. Right? We're going to keep this going for the next couple of sprints. Let you get comfortable with the data model. Let you get comfortable with working with a specific set of use cases. And once you're comfortable, in a couple of weeks, we're going to rip that out of your hands and we're going to give it to someone else. You were ripped out of a particular team, and you're going to now have to work on somebody else's code. It happens where we no longer are working on our own code. We have to manage, maintain, and work on somebody else's code. Everything, we all love that. So we'll talk about some of the challenges of having to perhaps deal with other team folks that they might need to support us, that we might need to borrow some folks from other teams, that they might need to do some knowledge transfer and teach us about their particular implementation. But eventually we're going to have to own that particular code, even though it wasn't originally ours. So let's keep this this breakout for the next couple of sprints. Let's see. This is a data model that you might have come up with on your own for the ongoing assignment. It might look slightly different from what you might have come up with, but here might be something that might be equivalent to what you already have. So here we have, let's see, we have the user class, obviously, that can have, which is related to many different classes over here. We see that there's a many-to-many relationship between a user and a service, right? And it's implemented by this class, this mapping class called user_service that relates many users to many services. Right? Notice that the many-to-many here is implemented through two one-to-many relationships, right? If this were pure UML, right, we could have just written a single line between these two and would have said star star, yes? But because we know we're going to have to implement this as a relational database, we know that the only way to implement that many-to-many in a relational database is to have a class, a table, an additional table that maps the two tables, right? That has foreign keys that go out to the primary keys of those two tables. Yes. So oftentimes we go ahead and actually document the this new table that is peculiar to the way how the particular database that we chose. In this case, is a relational database. If this were a non-relational database, perhaps we won't even need to do this, right? If it was a NoSQL and this was MongoDB, right? We could have just drawn the line and said star star without having a mapping table, right? Because each one could have an arrays of foreign keys here, an arrays of foreign keys on the other side, and actually implemented the many-to-many. But because it's a relational database, we know that the only way is to have a mapping table in between. We've documented it, so what used to be a many-to-many became two one-to-manys. So oftentimes this relationship we oftentimes refer to as a mapping table that maps records on one table to records on some other table. And the only fields in that mapping table is foreign keys, right? Foreign keys that relate to primary keys of the original classes. So same thing here that maps a many-to-many between the services and the category. One service can be many categories, but one category can have many services. And same thing, this is a many-to-many relationship, right? That again, if this were pure UML, we could have just drawn a line and said star star between the two. But we have instead provided a mapping table in between. The process of going from one line many-to-many, but providing an actual class oftentimes is referred to as reifying, right? Reifying, of converting something that is very abstract into something that's more concrete, something that I can actually implement with a relational database. I notice that we have a couple more many-to-manys. We also have a user related to many users related to many questions, right? One user can answer many questions, but one particular question can be answered by many users. Yes? And we have a many-to-many here. Notice that instead of using that nomenclature up there of a mapping table, we've instead used this different notation, right, which is referred to as an association class, right, which is basically the same thing, right? It's basically that same implementation there of a mapping table, right, which has foreign keys to the original two tables, but it has additional fields, right, that describe that relationship, that say, yes, this is an answer for these two. Oh, and by the way, these are the answers, right? Those, I'm describing that relationship, right? If this were a true-false question, that's a true-false answer. If this were a multiple-choice question, that is the multiple-choice answer, and so on and so forth. So it's physically the way it's implemented is identical to the mapping table, other than that the mapping table only has foreign keys, whereas this one has foreign keys plus additional fields. Make sense? Right? It's just nomenclature. Let's see what else. Also, so this same many-to-many with an association class is also repeated over here, where a user can answer many questions, but one question can be answered by many users. And we have an association class here that provides the actual answer to a particular question answered by a particular user. Okay? Again, two foreign keys, and the answer saying that this is the answer for that question and that particular user. A three-way relationship between these three. Make sense? What else we have here? And notice that these are compositions, right? So that if I remove a user, it makes no sense to keep track of the relationship to a service. Or if I remove the service, there's no point in keeping track of the relationship to a user. Same thing with the categories. Notice there's a enumerated data type over here, right, where you have a brand new type called question type implemented that has these three valid values, true, saying that a question can be of many types. Right? Notice that the frequently asked question is just one type, right? Say it can be the question can be an open-ended question. How many employees do you have, or how many can you tell me your best employer, right? Tell me about your best experience. There can be just open-ended, long-form questions and answers. So the answer is just a string, right? But in the service questions, these are a little more structured questions. Right? They're not open-ended questions. They can either be a true-false question, where you can have a question here, right? And this question presumably it's true-false, and it would render as a true-false question, allowing you to select either true or false. Or multiple choice. If it's a multiple choice question, then here's the multiple choice question. But then also there would be the actual choices from which you can choose. And this would be a comma-separated list of choices from where you can choose. Or it could be a range question where you have a minimum and maximum, right? Where it would render maybe two fields where you can type in the max, type in the minimum. What's the biggest size house? How many bedrooms or whatever, right? Those kinds of questions. And depending on the type, you'll have different answers. If it was a true-false question, you'll have a true-false answer. If it was a multiple choice question, you'll have a multiple choice answer. If there's a range, then you have a min and a max answer. Okay. Again, if you want to use this to finish off some of your outstanding design questions, feel free to copy or ignore. If you have something better than this, then maybe you want to stay with whatever you have, so that you can close those. You can finish those up, bring them up to the new sprint, finish them off, close them so that we can focus on the upcoming tasks. Okay. All right. Any questions? Yes.
So, hold on. I'm waiting for a second.
Well, he had a question. What's up?
So on the service answer association tables, are those actual tables?
Yeah.
It's just like the map.
Yes, that would be. Yeah. Okay. Just a different notation, but it's the same thing. Yes.
So if we do have to push something back to the next sprint, how would we deliver it? How would we deliver it? Would we just tack it on to the next deliverable?
Yes. Yeah. And obviously on our end for the TAs and myself, we're going to have some administrative juggling of being able to move back and forth between because Blackboard is very strict about due dates, about 1 week and whatnot, right? Whereas agile things just move, right? Are agile things do spill over to the next sprint, all right? Anything else? Yes.
So kind of going off that kind of solution where we're requiring tiered tickets, should we link those tickets in like the Blackboard solutions, make some written assignment of PAs, like what do we need to do about that? The whatever was listed there, right? If you finished it in the next sprint, but something that was due the previous sprint, just go back and update your submission. You can submit it multiple times, right? And we'll just have to give you credit for whatever is not there, but now it is there. All right. Yes.
Does it matter whether or not we include ID numbers in things like users?
ID numbers. Typically, if this were pure UML, we would not include any foreign keys, any primary keys. But it's often useful just for communication purposes. And we don't document for keeping the document around in Agile. So it's most for just us understanding, right? If it makes it easier to understand that indeed there is a primary key, then by all means add it, right? Again, if this were a relational database course, we might say, well, no, don't do that, right? But this is Agile. We use the diagrams to communicate, right? And for clarity, we would add those kinds of things. Yes.
Yes. So similarly, you said that like including the mapping table would not be
Yeah.
But is that fine for the class diagrams for the design?
Let's see. So it's going to create an actual table. If you're using the JPA mapping, right? Presumably, it would create the table for you, and it has a default table that it would create for you, unless you give it the join, where you name the table and the foreign key and primary key. Typically, you would want to document the fact that you're using that particular class or that particular table. Yeah. Okay.